Hello, this is going to be a short tutorial on how to use Excel to make your lab measurements easier and even writing your reports easier. So we're going to pretend, right? We're going to use the data we used from the gravitational acceleration lab, where we dropped the metal weight and recorded the position every 60th of a second. So let's just say this is the data I read off from the tape and had the meter say. So that's a good place to start. So I'm just going to copy that data and put it here. Paste it in here, right? And of course, you can just read this down. And this is the position. So this is Y then in meters, right? I'm going to go ahead and make sure and label all the columns. Okay. We also have the dot number. So dot number. Number. So here will be the first trick. We want this to be 1, 2, 3, and so on. We could just enter it manually. We could also just say that this cell equals the one above it plus 1. And if we go ahead and just drag that all the way down, we'll see that we get the dot number moved all the way down. All right. Now we want the time. This is in seconds. Okay, I'll move this over a little bit to give myself a little more space. And on this side, I'll make an example. In this case, it'll be simple, but sometimes you'll have quite a few variables. You'll have the value, and you'll have the units. So the variable is the time step. Value just equals 1 divided by 60. And the units are seconds. Okay. So the time in each case is just going to be the data point times the value, 1/60th of a second. All right. Now, you might think you could just drag this down, and you can try that, but you see what happens here is that it works for this cell because this is the dot times the value, but it doesn't work for the next cell. Right? The next cell brings the dot number down, which you want to do, but it also brings the value down, which you don't want to do. You want to stay there. And in Excel, the way we tell something to just stay at the position it's at is to use the dollar sign. The dollar sign means don't move when I copy the cell down. So now when I copy the cell down, you can see it just does the increments in 1/60th of a second. And if you're ever curious about what calculation the cell is doing, you just highlight the cell and then click up here on the equation box, and it will highlight the numbers that it's using for the calculation. So this is doing it correctly. All right. So it's helpful to just look quickly at what the data looks like in time. Of course, you're going to use Logger Pro to actually make your finalized plots. But if you just want a quick look at what's going on, you can just highlight the X column, hold Control, highlight the Y column, and say Insert, Chart, Scatter Chart. And you can see, okay, this is what we think it should be. This is looking about right. We have time on the bottom axis, position on the Y axis, so we have this quadratic fit. Okay, so that's looking about right. We won't use that, but it's nice to just look at the data every once in a while to see that you're not doing anything too crazy. Next, we want to look at the velocity. So to get the velocity, we need to look at the change in time. This, of course, is also in seconds. And the change in time just equals the new time minus the old time. Again, we can move this down. And of course, this is just the same value as this over there. That's fine. And we need the change in position, dy, and this is in meters. So dy in meters is just the new position minus the old position. Copy that down. And now we want the velocity. The velocity just equals dy, in meters per second. The definition of the velocity. So now we want dy, this guy, divided by dt. which is this. And now we can move that down as well. Okay, just to make sure everything's going right, let's look again at the time-dependent velocity. So highlight those cells, hold down Control, highlight these cells, insert, graph, scatter plot. All right. We know that with a constant acceleration, the velocity should have a constant slope. It should increase linearly in time. And good. That's exactly what that looks like here. We have some scatter due to the error in our data points, but that should be fine. So as a good first look, that should be fine. All right. Another trick to know that you see how this title of velocity is kind of overlapping going into the next cell. A nice trick is that you can just highlight the column and double click on the border and it will automatically increase the size. You can do that actually for the whole Excel spreadsheet and just click on the border and it will resize everything. Also, you notice that we have a whole bunch more significant figures than we need. When you have more significant figures than you need, you can change the amount that's shown by using this increase and decrease decimal points, right? So that should be fine there. I can highlight these guys and do the same thing. We don't need that many, right? We just need that. And you can change this depending on your precision and time and position and the like. All right. So that snugs that up a little bit. We have position, we have velocity, and now we need acceleration. Acceleration just equals dv dt by definition, and the units are meters per second, and we're done with that. So now we need to write that formula, right? So this is going to equal, all right, this is going to equal the change in velocity. So this is going to equal this cell minus this cell, right? That's the change in velocity, the new velocity minus old velocity, divided by the change in time, dt. Right? And again, we can just copy this down. Okay. Here you notice that sometimes I lose data because I need 2 points to look at the change in position. That's why there's no data here. And I need 3 points to look at the change in position. So that's why there's no data here. But again, let's take a quick look and see what this looks like. So the acceleration should be constant at 9.8. So let's take a look and see what we got. Insert, scatter plot. All right. So we can see that there's a lot of error in the scatter plot, right, in the position. But it does look like it's centered somewhere around 9.8, right? So it's not totally out of bounds. So things are looking all right to start with, okay? But now what we want to do is let's spend a second and clean things up a little bit. So a nice way to clean things up is to highlight this. Let's put some lines there just to make it clear. Let's make sure this is looking all right. All right, dv/dt. Typically, you make these guys on top bold. All right, we'll clean it up a little bit more in a second. The next thing we want to do is we want to find the average acceleration. All right, in Logger Pro, we're actually going to do the fitting of these data points to find the acceleration. But with this data here, the first thing we want to do is find the average and the standard deviation and those kind of things. So to find the average, we can just say equals an average, A-V-E-R, average. And then you just highlight all the cells. That gives me the average value, all right? So this is the and of course you can change the justification there, right, left, as you wish, okay? So this is the average value of the acceleration, which is not totally out of bounds. 9.8 to 10.4, that's not a totally crazy kind of distance away in meters per second squared. Now what we want to do is find the standard deviation. So the standard deviation, as you recall, is the square root of the sum of the square of the difference is divided by n. All right. So to do the standard deviation, the first thing we need to do is find the difference between the value, this is the value, minus the average value. But remember, the average value is just going to stay the same the whole time when we drag it down. So we need to put the dollar signs here so that it, whoops, and you'll get that if you do a little typo here. I put a percent sign instead of a dollar sign. So I put the dollar sign, and again, I can drag that down. And this column is just, let's call it the acceleration of the I point minus the average acceleration. Okay, that's just kind of shorthand for that. Okay, so that's the acceleration minus the average acceleration. We need to square this value. Okay, so we square this value, this just equals this, and we use the caret, whoops, where are you at, caret? So this squared, the caret just means to the power, so this is squared, all right. So this is the difference, this is the square of the difference. Then we need to sum those up, all right? So we sum those up, and again, as simple as just writing sum, and then your bracket, and then just highlight those all together. Let's make sure we did this right. Yeah. We sum those up. That equals the sum. And now we want to divide that by n minus 1. So the sum of the squares, and then we want this to equal that, divided by n, right? So we have 19 minus 2, so we have 17. That means n minus 1 is 16, right? So there's 17 values here, so n minus 1 is 16. Okay, so we divide by n, divided by n minus 1. Right. Let's go ahead and move that to the right as well, so it's clear what we're doing. And now we want to take the square root of that whole thing. So equals and square root is just SQRT, and then the value. All right. So this is sigma. The standard deviation. All right. So that means our value here that we found is the width of the distribution is 10.4 plus or minus 7. Right. So there's a big standard deviation, but that's not unreasonable looking at our data set here on the bottom right. Right. We see that the data set spans for something like 0 to around 15. So the standard deviation of around 7 is not bad. All right. We also want to find the standard deviation in the average. This is how far off the average can be. And this is just equal to this number divided by the square root of n. And in this case, remember where our 17 values, so the square root of n. Okay. So this is n equals this values. Okay, so that means we found that the acceleration of gravity is 10.4, right? Plus or minus 1.7, right? Certainly very reasonable, right? We know the value should be 9.8, and 9.8 is well within those error bars. Okay. So now to present this kind of data, once you have it in this form, you've done your calculations in this form, it's very easy to just present your data also in the same format now that you've made it. So let's go ahead and clean this up a little bit. So we can do the same kind of thing here. We can just put boxes around it, do this, and this is the error. This is the error calculation. And we'll put that in bold. Okay. And now, right, if you want to make it look like, you can just change your borders here so that you have thick borders, right? And it's nice to delineate your dependent and independent variables, so your times and your positions, right? And we also have these calculated values. So something that looks like this. All right. So now that we have the data, right, we can start to think about our lab report, and there's a few different ways to put this in your lab report. One is you can just highlight everything, right? So you can just highlight this stuff and do Control-C and go to Word, for example, and Control-V, right? So it'll just put everything in there. Let me zoom out a little bit, right? So it just put everything in there, and you can just continue typing, right? So table 1, table 1, caption, right? And just keep typing report. So that's one way to do it. I personally am not the biggest fan, right? That allows you to adjust all these things, but Word can sometimes be fussy about that. Another option, just paste all the cells like that. Another option is to go in Excel like this and just do Alt Print Screen. So you're going to hold down the Alt key and hit the print screens key. When you do that, it takes a picture of what's on your screen. And now we can go back to Word and you do Control-V, and you see it just took a picture of what was on my screen. If I highlight that picture and type format and go to crop, now I can crop just the part I want of those calculations, like so. Expand that out, and I have a very nice graph there. All right. And then you can have your data set and just have that easily as part of your data. All right. A couple other things, right? As we're moving through here quickly, you'll notice that I didn't pay so much attention to my significant figures. You're definitely going to want to do that for your report. So these significant, right, there's too many significant figures here, right? So we can just highlight these guys and change that amount of significant figures back to a more reasonable level, right? And you can do the same thing here if you wanted to. Okay, and once you have it copied into Word, you should be good to go. The other option, if you don't like any of those other options, is of course you can just print the data. So you can highlight it, highlight this kind of thing, and do Control-P. And right, it's a little bit of a pain, right, because you don't know exactly what it's going to print. You got to change the orientation to landscape and get the right page, and you have extra stuff on there you don't want. So that's why I prefer to do the screenshot method. All right, and of course you'll want to save this plot save this data as an Excel spreadsheet on your computer somewhere where you know where it's at. All right. The very last thing you'll want to do with Excel is you want to use this same data to make your plots. And that's easy enough. You can just highlight any column, and let's highlight that. And you can do Control-C And then you can just click in Logger Pro and do Control V, just like I did here, and it will paste that data in Logger Pro, and you can just plot that way. So you don't have to ever retype the data. So I hope that helped you out. Let me know if you have any problems, and hopefully that saves you some time moving forward.